Hi, this is Dr. John Bergduff. In a previous video, we explored what is meant by the exponential function with base A and how to graph any function that fits in that category. In this video, we want to look at exponential functions more generally and see how those can be related back to the exponential function with a given base. I'm going to change my camera here, and we're going to look at some examples that we're going to draw. So the first example is going to be basically a review of what we saw in the previous video. If your equation is of the form f of x equal a to the x, where the a is any number that's greater than 0 but not equal to 1, that is called the exponential function. And when you graph the exponential function, let's say again with base a, there's some key points that you want to remember to graph. And if you know these key points and a few other facts, you can get a graph pretty easily. So the key points are these: thinking about x and y, and thinking about simply three values of x, -1, 0, and 1. If x is -1, y will be 1 over a, whatever that a is. If x is 0, y is 1. Every one of these basic graphs go through the point 0, 1. And if x is 1, then y is a. So if I was looking particularly at f of x equal 2 to the x, my key points for that particular graph would be -1, 1/2, 0, 1, and 1, 2. Let's plot those points and then remember a couple other things while we're going. So -1/2 is right here, 0, 1 is here, and 1, 2 is right there. Now, this is not very many points, but what we remember is that the graph of any exponential function with, if you're looking at the exponential function with base A, all of those will have a horizontal asymptote along the x-axis. If the a is positive, the graph is going, if a is greater than 1, the graph will be increasing. If a is between 0 and 1, it'll be decreasing. So the general shape of this graph, it'll hug the x-axis as a horizontal asymptote, pass through these points. And if you want to plot more points to make it more accurate, of course you can. But just to get a general shape, it would look like that. Now, a couple things I want to notice. If you think about other occasions where we've looked at shifting and stretching graphs, almost always every basic graph we've looked at has gone through the origin. I just want to mention that the basic graph, f of x equal a to the x, in this case a is 2, does not pass through the origin. It passes through a point 1 unit above the origin. Keep that in mind as we move on. Now, what I want to do is I want to put together what I have observed about the basic function with base A with ideas I have learned previously about how graphs shift and stretch depending on their equation. So I want to look at this graph, and I want to notice that inside that function, or in the function, I see 3 to the x. That would be a basic exponential function with base 3. But I have this -4 at the end, and I remember that when I have a number tacked on to the end, the effect of that is that it shifts the graph 4 units down. So let me start with that and think about what that does. So think about where the origin goes. If you always focus on the origin, you'll be in good shape. The origin is going to shift 4 units down. 1, 2, 3, 4. And on an exponential function, or any other function that has asymptotes in it, the asymptote structure will follow along that shift. So ordinarily, we have the x-axis being a horizontal asymptote. If that entire thing shifts down, we'll actually now have a horizontal asymptote here passing through 0, -4. And I'm going to draw that asymptote as a dashed line. Now, I am going to think about the basic points or the key points that would go with the more basic graph, y equal 3 to the x, and talk about how we're going to structure that based on how the origin has moved. So from the example we saw before, we only think about these points, and if x is -1, y is 1 over a, and that's case to be 1 over 3, then you also would have 0, 1, and 1, 3. Now, this point right here where the origin moved is not going to be a point on the graph, but imagine that as the new origin and measure everything from there. So starting from the new origin, imagine where these 3 points would be. Basically, you want to think about it this way. Compared to the origin, this point is 1 unit to the left and 1/3 of a unit up. So starting at the new origin, go 1 unit to the left and 1/3 of a unit up, just kind of have to estimate that. Compared to the origin, this is no units in the x direction, no units left or right, and 1 unit up. So remember that in the more basic graph of just a to the x, you didn't go through the origin there either. You went through 0, 1. This is where 0, 1 goes. And this is saying that compared to the new origin, there's a point 1 unit to the right and 3 units up. And this graph would approach the horizontal asymptote, be increasing because the base is greater than 1, and pass through these points, sort of like that. So I put together the idea of transformations with this idea of a basic graph. Let's look at a couple that get a little bit more involved where there's more things happening. So suppose we are looking at f of x equal 1/2 raised to the x minus 3 power plus 2. If I want to sort of think about a basic graph, this is going to build on the graph of y equal 1/2 to the x. And if I make some ordered pairs just for that, if x is -1, y would be 1 over a, so 1 over 1/2, but 1 over 1/2 is 2. And if x is 0, y is 1, that point is always there. And if x is 1, y is 1/2. My basic graph, y equal 1/2 to the x, would pass through these points. But the extra numbers that I see in the equation have an effect. Notice that I still have a number that's added on at the end of the function, but I also have a number that's inside the function, replacing the x. This is going to result in a shift horizontally. And if you remember, the signs kind of go opposite of what you expect. If you see an x minus 3, that means that the graph is going to shift 3 units to the right, not the left. Sort of the opposite of what you expect. And the number on the end tells you a vertical shift, so it also shifts 2 units up. Use that to describe how the origin would move. Think about what becomes of the origin. If the origin is shifting 3 units to the right and 2 units up, the new origin, so to speak, would be right here. Now that's, again, not going to be a point on this graph, but it's going to be important for the graph. The important thing also to remember is the asymptote structure is going to shift with you. So the asymptote is the x-axis. If you shift the x-axis to the right, you don't really see any difference. But when you shift it up, you do. So there'll be a new asymptote shifted 2 units up from where the old one was, and I draw that in. And now I use these basic points to measure everything from the new origin, which I've made as a slightly visible blue dot there. This point is 1 unit to the left and 2 units up relative to the origin. So compared to the new origin, 1 unit to the left and 2 units up. 0, 1 would be no units left or right, but 1 unit up from the new origin. And then this point is 1 unit to the right and 1/2 unit up from the new origin. And you can see sort of that this is going to approach that horizontal asymptote, remembering that if the base is between 0 and 1, the graph is decreasing. If you'd like to plot more points, you're welcome to, but really this is enough to get a sense of shape. So I am going to just kind of draw it like this, coming down through these points, and then approaching this new asymptote as carefully as I can. You can see my hand kind of wiggled a little bit there, but approaching that asymptote. And that's all you have to do. So putting together the idea of what the basic V exponential function with base A looks like, plus what you know about shifting and stretching. Let's do one more, because this one has one more quality to it that I want to point out. So you can kind of tell that the basic exponential function that you're going to be building on is going to be y equal 4 to the x. Forget that negative sign for a minute. We'll come back to that. And so the key points that you would have would be 0, 1/4, negative 1, 1/4, 0, 1, and 1/4. Negative 1, 1 over a, 0, 1, and 1a. Now, what all is going on here? This negative 5, x minus 5 inside the function, that's a horizontal shift. And that's going to be a shift 5 units to the right. And the plus 6 on the end is going to shift you 6 units up. The negative sign, what does that do? You might remember that a negative sign in front of a function reflects the graph over the x-axis. So instead of something that goes above the x-axis or above the asymptote, it's going to go below. So how do we do this? Well, first of all, focus on where the origin goes. Origin starts here. It shifts 5 units to the right and 6 units up. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. I'm just going to recount that. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. This is the new shifted origin. The asymptote goes with it to the right and then up. So I want to draw in the asymptote. Now I'm going to measure my key points from the new origin, but because I'm reflecting over the x-axis, where I would ordinarily count up, I will count down. This would tell me that there's a point in y equal 4 to the x, 1 unit to the left and 1/4 unit up. But because we're reflecting, we would go 1 unit to the left, 1/4 of a unit down. This point would tell me that there's a point, no units left and right, but 1 unit up. No units, oh, I put this in the wrong place. I counted from the wrong origin. Excuse me. This is my origin. So 1 unit to the left, 1/4 a unit down is right here. Pretend you don't see that. This is the right point. Measure everything from the new origin. Lost that a little bit. 0 units left and right, 1 unit up. But instead of going 1 unit up, we're going to go 1 unit down. And this compared to the origin would have been a point 1 unit to the right and 4 units up. Again, let me not lose the origin again this time. 1 unit to the right and 4 units down. 1, 2, 3, 4 because of the reflection. So instead of this graph being above the asymptote, it's going to be below. We'll ask some follow-up questions to this as we go. This is still a horizontal asymptote. And it's going to turn and go off this way and continue on. And that's reflected. So they might ask you a couple follow-up questions on this and any of the graphs. They might ask you to specify what is the domain of the function, what is the range, and they might even ask you what is the equation of the asymptote. Let's talk about all of those questions and see how they will help us. So, domain is the set of all values of x that are used in this graph. And if I look from left to right, I realize that this graph includes every possible value of x. This just continues on. So the domain is from negative infinity to infinity. The range is the set of all values of y. And if I look from bottom to top, I use all of these values of y up to the asymptote, but no farther. So my range goes from negative infinity to, and this is 6, so negative infinity to 6. Should I put a square bracket or a round parentheses? Well, the idea of the asymptote is you never actually get to that point, so you want a parentheses. And finally, what's the equation of the asymptote? It's a horizontal line. All horizontal lines have an equation of the form y equals something. And because it goes through 6, it would have to be y equal 6. So I hope that's very helpful. And now you can graph lots and lots of exponential functions.